morning. Happy birthday to Malcolm X. Welcome to All This Math. This is Professor Parker. And today we're going to do some long division problems because my nephew Amir down in Baltimore asked me to help him out. Actually, my sister Hanifa, his mom, asked me to help him out. But hopefully Amir is watching and we're going to learn how to do some long division. And we also have my daughter Asada here with us. She's going to be practicing some long division also and helping me out. Right, Asada? Mm-hmm. That's what's up. All right, so one thing I will say, whenever you're doing long division problems, and this is for parents too, if you're trying to help your children with their work and they're trying to help your children work through long division problems, they should always either have their multiplication facts memorized or they should have a multiplication table from factors 0 to 12 at a minimum nearby, right? So today we have our multiplication table up here. This tape is a little cheap, or I should say inexpensive, so hopefully the poster doesn't fall down on the floor. And as you can see, this multiplication table poster has been through a lot. It's been in a lot of classrooms and moved off of walls and moved to other classrooms. It's battle tested, right? But it still works because it has the information, right? It may not be pretty, but it's going to get the job done. All right, but we need multiplication in order to do division because multiplication is the opposite operation from division, or the inverse. And likewise, division is the opposite of multiplication. So, a little bit of terminology. This, of course, is your long division sign. This right here. And you might think of this as a house. All right. Now, the number inside the house is called the dividend. The dividend. The dividend, which also can be defined as the payout you get when you invest in a stock that pays a dividend. All right, you get quarterly returns, all right, which is a certain percentage of that stock price. That's another conversation for another video. But this is called a dividend. In this case, 172 is the dividend. This number outside is called the divisor. That's the divisor, right? That is the amount of pieces that we're going to break this dividend up into. So when you divide something, you're dividing it into a certain amount of pieces. So we should always understand what it really means to divide. What does it really mean to multiply? What does it really mean to add? What does it really mean to subtract? When we're dividing, we're taking a number, in this case the dividend, and we're dividing it into a certain amount of pieces. All right? Or we're dividing it among a certain amount of people. All right? There are different ways to look at division, but mainly we can look at it as we take the dividend and we divide it into this many pieces. And then the quotient, which will be written up here, tells us how large those pieces are. So we want to know how big those pieces are. If I take this number and I divide it into this many pieces, I take this number and I divide it into this many pieces. So I'm taking 172 and I'm dividing it into two pieces. Now the thing about the pieces is they have to be equal pieces because we want to be fair, right? Like when you split money with somebody, you want them to be fair. You want them to give you the same amount that they have, right? If that's the decision that you made. Right, Asada? Mm-hmm. All right. Now, when we do long division, I want you to think about these three letters. DMS. 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 Now, what do the letters DMS stand for? The letters DMS stand for divide, multiply, subtract. Divide, multiply, subtract. Divide, then multiply, then subtract. Because that's the pattern that you're going to follow when you do long division problems. You're going to divide first, then you're going to multiply, then you're going to subtract. And I'll show you. So the first thing we're going to do is we're going to say, okay, well, we go through these numbers, these digits one at a time. And we say, okay, can 2 divide into 1 as a whole number? We say no, because 1 is less than 2. So 2 can't basically fit into 1, right? The number 2 can't fit into the number 1, right? So we skip this space. We skip that space. And then we say, okay, well, what if I look at this as a 17? See, first we looked at it as a 1, and we acted like the 7 and the 2 weren't there. But now we're going to act like the 7 is there. We're going to look at this as 17. So then we say, we're going to do 17 divided by 2, which really means, or another way to think of that is, how many times does 2 go into 17, right? Now, we go to our multiplication table and we say, okay, well, these are the 2's, right? This is the 2 row, right? I don't see a 17 on this row. So that just means that 2 doesn't go into 17 evenly, right? But 2 does go into a number less than 17 evenly. And that's what you always have to ask yourself. So parents, have your children think about these questions. How many times does 2 go into that number? And if it doesn't evenly, how many times does it go into the number that's closest to 17? So for example, think about your 2s. 2 times 1, 2 times 2, 2 times 3, 2 times 4. What is the closest number to 17 that's less than 17? 16, right here, right? So then you say, well, how many times does 2 go into 16? Because 16 is the closest number to 17 that is at the same time less than 17. Asada, you want to say something? What do you want to say?
2 goes into 16 8 times.
Exactly. You're sharp. You're going places. So, like Asada said, 2 goes into 16 8 times. So you're going to take that 8, that's going to be part of your quotient, which goes above the house, right? Or above the long division bar. And you write that 8 above the 7, right? Now that's our division step. The M stands for multiplication. So now what are we going to multiply though? We multiply the divisor by that number. So 2 times 8 is, Asada, what's 2 times 8?
2 times 8 is 16.
Yes, 2 times 8 is 16. So then you take the 16 and you write it right here. And then the S stands for subtraction. So you see the pattern? DMS. Divide, multiply, subtract. Divide, multiply, subtract. So then you have this minus sign. And now we're going to do 17 minus 16, which equals 1. Now, then we start the process over. DMS again. Now we want to divide again. So we try to divide 2 into 1, and we say, well, how many 2's fit into 1? None. None. No whole 2's can fit into 1 because 1 is too small. So this is how you fix that problem. You look back at your dividend and you say, are there any extra numbers that I haven't used yet? And there is. This 2. We haven't used this 2 yet. So the 2 comes down and you write it next to the 1. So now you have a 12 right here. So now let's try to divide into 12. So we say how many 2's go into 12? And then you go to your 2 column. This is why you have to know your multiplication facts. You have to. And if you don't, have a multiplication table right there on the table with you. On the paper, on your paper, or look in the back of your composition marble notebook. You have to, but I would suggest that you memorize the multiplication table, at least from 0 to 12. Or really from 1 to 12. At least from 1 to 12. You should go beyond that. You should go up to 15, 20, 25. Memorize as much as you can, because the more you memorize, the less work you have to do mentally, and the less you have to use your calculator. So now I say, okay, how many 2's can go into 12? Here's the 2 row. Boom, 12 is right there. 12 is right there. So, Sada, how many 2's go into 12?
6.
6, exactly. So that's our division. So you write the 6 above the 2 that we just used to make a 12. So now, then we multiply, because that's the M. Remember, we're doing DMS. DMS. So now we're going to multiply the 2 outside by the 6. Just like before, we multiplied the 2 by the 8 to get 16. Now we multiply the 2 by the 6 to get 12. And we write that underneath of this 12. And then the S stands for, of course, subtraction. So then we're going to do minus, and 12 minus 12 is 0. And whenever all these numbers are used up, there are no other numbers in the dividend to use, right? No other numbers to bring down. And then you have a 0 underneath of this bar, right? You have a 0 right here. That means that the remainder is 0. So that means that 2 goes into 172 86 times. Or if I take 172 and I divide it into 2 equal parts, right? 2 equal parts. Each part is going to have 86 in it. So if we have $172 worth of birthday money, right? Or graduation money, and you want to save half of it and spend half of it because your mother's being responsible or your father's being responsible and telling you should save for the future so you can invest in your future. You say you need to save 50%, which is also half, but then you can spend the other half if you want to, right? you would have to save $86 and then you'd have $86 to spend. That's the purpose of knowing how to do division. All right? I mean, that's only one example. But there are literally thousands of examples where division is used in our everyday life. That's why we need to learn it. We need to understand it. Even if you let a calculator do the work for you, you should at least understand what's actually happening. Even if you let, I'm going to say that again. Even if you let a calculator do the work for you, you should still understand what is actually happening, what's actually taking place. So that way you'll know when to use the calculator for this. You'll know when you're confronted with a situation where you need to actually divide. Because some people don't know when they should divide or when they should multiply because they don't understand the concept of division and they don't really understand the concept of multiplication. So they find themselves in school frustrated and just making guesses. So what we have to do now, especially while we have may have more time now while we're home, think about why we divide and why we multiply and in what situations we do that. Right, Asada? Mm-hmm. All right. See, Asada, you're like my hype man. That's what's up. All right, now, let's do another example. Now we're doing 259 divided by 3. 259 is the dividend, right? And 3 is the divisor, right? And we're going to find the quotient that will be written up here, right? That's what we're going to do. So, we're going to follow these 3 steps, DMS, all right? I should get a DMS t-shirt, right, for long division, right? DMS, right? So, tell people to remember what they got to do. So, divide, multiply, subtract. So, first we're going to divide. So, I want to see how many 3's fit into 2. 2 is too small. So, no 3's can fit into 2, all right? So, I got to skip the 2, and then I go over here and I say, well, what about 25, right? How many 3's fit into 25? So, we're really doing 25 divided by 3, or asking how many 3's fit into 25. So I go to the 3 row on the multiplication table, and I go across, and I see 3, 6, 9, 12, 15, 18, 21, 24, 27. Oh, I don't see 25 in the 3 row. Because 3 does not divide evenly into 25. But, Asada, what is the closest number to 25 that 3 does divide into evenly?
24.
Yes, 24. 24. And 24 is right here. 24 is right here. 24 is the closest number to 25 that 3 does divide into. So you ask yourself, well, how many times does 3 divide into 24? How many times?
Eight times.
8 times. There you go. 8 times. So then you take that 8 and you write it above the 5. Right here. That's our division step. Now it's time for our multiplication step. So now we do 3 times 8. And what is 3 times 8? Asada, who is named after Asada Shakur. What is 3 times 8?
24.
24. You ain't even need to use the table, did you?
No.
Right. So 3 times 8 is 24. So you write 24 underneath of the 25. And then the third step is to subtract. So you write your subtraction sign. So now you actually will subtract. 25 minus 24. What's 25 minus 24? Do you know that too? If you have 25, you take away 24. How many is left over?
It will be 19.
No. 25 minus 6 is 19. If you have 25.
It's 24.
But what if I did 5 minus 4? What's 5 minus 4? 1. And what's 2 minus 2?
0.
0. So it's just 1. 25 take away 24 is 1. All right. Now, we did our 3 steps, our D, our M, our S. Now we start the process over again. So now I'm trying to divide 3 into 1. I want to know how many 3's fit into 1. 1 is too small. 3 can't fit into 1. A whole 3 can't fit into 1. Right? So that means I need to create a different number. So I look at my dividend and I see if there are any digits that I have not used yet. And I see there's a 9 right here. So the 9 comes down. And now you have 19. Now your 1 transformed into a 19. Right? So now we start the process over again. DMS, DMS, DMS.
Do I have to write it again?
So 3, write what again?
DMS.
We don't have to. You want to? We can. It is that important. DMS. In fact, let's do this. Exclamation mark. because it's that important. DMS. Now, how many 3's go into 19? Go to your multiplication table. How many 3's? Is 19 in the 3 row? Or the 3 column? 19 is not in the 3 row, right? But, Asada, what number is closest to 19 that 3 does divide into? And it's less than 19.
18.
18, right? So now we're actually saying, okay, well, how many 3's can fit into 18? How many?
6.
6, exactly, right? So that means that we write a 6 up here next to the 8, right?
Mm-hmm.
And now we do the second step, multiplication. So we do 3 times 6. And what is 3 times 6?
18.
18. So then we write the 18 underneath of the 19. And now we're going to do the third step again, which is subtraction. 19 minus 18, what does that equal?
19 minus 18.
Yeah, what does that equal?
1.
1, exactly. See the coincidence? 25 minus 24 was 1, and now 19 minus 18 is 1. Now, we don't have any other numbers to bring down, right? Now, if this was a little more advanced, we could get into the decimals, but we're not doing that today. We're not going to go to the advanced level and add a 0 and keep adding zeros and, taking this 86 out, because we could take it out further. But for now, what we'll do is whenever we use up all the numbers in the dividend, and we have a number written down here, that means that number is called a remainder. It's a remainder. It's a remainder. It's a leftover number, right? Like when all the food is served, but it's some leftovers. And some leftovers are remaining, and you put them in a Tupperware container and put them in a refrigerator for the next day. It's food left over, right? It's extra. So this number is extra. This is a leftover extra number, right? So what does this mean, though? So I'm going to put an R right next to that. Capital R, which stands for the word remainder. Remainder. That's another important vocabulary word. Remainder. Remainder. So what does this mean, though? So if I want to divide 259 into 3 equal parts, that means I can't do it with whole numbers. What I could do is, let's say I want to take $259 and divide it evenly among 3 people. What would happen is, one thing I could do is I could give each person $86, each of those 3 people $86, and then there will be $1 left over. Or if you got into decimals, we could divide this $1 into 3 equal parts, which would be about, not exactly, but about 33 cents. So each person could have $86.33. Or I could give each person $86 and I could just take this $1 extra and donate it somewhere. Donate it to somebody else, or just leave it. Or whatever, or do something else with it. I don't know. But, because remember, when we're dividing, we're trying to divide a number into an equal amount of parts. So I'm trying to divide this dividend, 259, into 3 equal parts. That's what I'm attempting to do now. So each equal part would have 86 in it. Whether it's 86 people, let's say it was a school trip and it was 259 students, and we got, it's not enough room for everybody to go the same day. So the school's going to break the trip up into 3 different parts. So some people are going to go on Monday, some people are going to go on Tuesday, some people are going to go on Wednesday. And what the school principal and the teachers want to do is they want to have an equal amount of students go each day. So what they would do is they would say, okay, on Monday, 86 students can go. On Tuesday, another 86 students can go. And on Wednesday, another 86 students can go. But then you got this 1 extra student. You probably would have to throw him or her in one of these groups. So one of the groups would probably have 87 people in it. Either the Monday, Tuesday, or Wednesday group. So these are just the different ways that we can use long division. All right? Amir, I hope you're watching, and I hope this is making sense to you. Unfortunately, right now, I can't look at my comments. I got to figure out a way to start, being able to look at my comments on the live so I can answer questions live. I got to figure that out. I'm going to work on that, though. All right. So last but not least, let's do one last example, because I got a tutoring session coming up, and also Asada has a Zoom conference call with her class that she's got to get on at 11. So we're about to wrap up. All right. So last long division problem, 328 divided by 4. Okay? Now, we want to follow these 3 steps. DMS. And what we're trying to do is we're trying to take 328 and divide it up into 4 equal parts. So we take 328 and we divide it up into 4 equal parts. In the last problem, we took 259. We wanted to divide it up into 3 equal parts. And in the first problem, we took 172 and we wanted to divide that up into 2 equal parts. Right? So now we look at the 4 and we say how many 4s can fit into 3? 3 is too small. So we can't do that because 3 is too small. We can't fit a whole 4 into 3. It's not enough space, right? 4 is a bigger number than 3. But what if I look at this as 32? Instead of 3, 32. How many 4s fit into 32? How many, Asada? Let's look at our multiplication table. Go to the 4 row. Go across. 16, 20, 24. 8. And lo and behold, this example is different from the other ones because 4 does fit evenly into 32. So 4 goes into 32 8 times, like Asada said. So you write the 8 above the 2. So then the second step is to multiply. So you do 4 times 8. And what is 4 times 8? 32. So then you write the 32 underneath of the 32, write your bar, and then the third step is to, what's the third step? What does the S stand for? Subtract. So you write minus, and then you do 32 minus 32. Now, what is 32 minus 32?
0.
0. Because you took away everything. So you write 0. Now, then you start the process over, DMS. So, does 4 divide into 0? No. Right? It cannot divide into 0. You can't have, 4 can't fit into nothing. It's not enough space, just like 4 can't fit into 3. So what I do is I look at my dividend. I say, do I have any numbers I haven't used yet? And I have an 8. So I bring my 8 down. And then I say, okay, well, 0, 8 is the same thing as just plain 8, right? Mm-hmm. So then I'm doing my steps over again. Divide, multiply, subtract. So how many 4s can fit into 8? How many 4s? 2. Exactly. So I throw the 2 up here in the quotient above the 8 that I brought down, and then I do multiplication. What is 4 times 2? What is that?
Huh?
What's 4 times 2?
Oh, 4 times 2 is 8.
4 times 2 is 8. And it's, again, I can't stress this enough. It is essential that we memorize the multiplication table. Even as an adult, it's never too late to memorize the multiplication table. Never too late. It can't hurt you. It can only help you. Right? So, 4 times 2 is 8. And now, no, 4 goes into 8 2 times. Now the next step is multiplication, right? 4 times 2 is 8. So then you write the 8 down here. And now the third step is subtraction. So now 8 minus 8 is 0. So there's no remainder. There's nothing left over. So 4 goes into 328 evenly. 4 goes into 328 evenly. And there's a rule about 4s, and that's why I looked at the ceiling, because I got all types of math rules written on my ceiling. I got formulas and everything. I do this for real. I'm serious about math, right? I'm serious about all this math, right? So there's a rule about 4s that in any number, if the last 2 digits are divisible by 4, then that number will be divisible by 4. And the word divisible means that the number divides into that number with no remainder. Divisible means that there is no remainder. No remainder. No leftovers. All the food got eaten. Everybody ate it all up. It's gone, right? Here there's no remainder. And if I want to take 328 and divide it equally among 4 people or among 4 groups, each group will have 82 people in it. Or if I want to divide this amount of money up among 4 people, each person will have $82. And now, if we ever, I'm always emphasizing and stressing checking our work. I'm always doing that, right? So let's say I want to check my work. The way you check a division problem is you take the quotient and you multiply by the divisor, and it should equal the dividend. So basically, it's like this. This is the dividend. Let's look at the last example. 328 divided by 4. 328 divided by 4. I'm saying that equals 82. So if this is correct, if it's correct, then I should be able to work backwards and get 328. That means I should be able to do 82 times 4, and that should equal 328. Now let's make sure. 82 times 4. 4 times 2 is 8. 4 times 8 is 32. And that's 328. So that's proof that this answer is correct. So this is correct. 82, this is correct. 86, remainder 1. Don't forget about the remainder. And this is correct. 86 with no remainder. All right. So Amir, I hope that's a good introduction and you gain some understanding, and you can do the rest of the problems on that worksheet that your mom sent to me on your own or with your mom's help, right? And then what you can do is then you can turn around, you can teach Zen how to do this, right? Because that's how this is supposed to work. We're not supposed to. We should never hoard knowledge. We should never hoard knowledge, right? We shouldn't be hoarders, right? We learn something and then we teach somebody else. You know, like the good brother here in Philly, named Frost. He says, he has this hashtag he uses that I like a lot. He said, he doesn't say each one teach one. He says each one teach 1,000, right? So if we start thinking about that, thinking about doing things in that way as a black community, then things will definitely change, all right? So again, Amir, take this, run with it, keep practicing, practice on a regular basis, teach somebody else how to do it, and we'll continue to progress. So to everybody else, thank you for tuning in. Hope you learned something. And if you have problems that you would like for your children to do, or your children need help with, or you need help with in terms of showing your students, please send pictures of those problems to the All This Math inbox or the All This Math DM. And depending upon the demand on that particular day, your problem might make it to this board, and I might be doing your problem. Asada, you want to say bye?
Bye.
All right, Asada said bye. Peace.